In this lesson, we will look at section 5.3, Interpreting and Sketching Graphs. In this lesson, you will learn how to apply what you know about functions to interpret graphs that represent different situations. We will look at characteristics of linear and nonlinear graphs and properties of distance time and speed time graphs. So the properties of a graph: the general shape, the scale, and the starting and ending points are important features. Arrows on graphs indicate that the graph will continue on in different directions. There are four types of graphs that we will look at in this section: linear, nonlinear, distance time, and speed time. As you can see by this graph here, we can see different properties that provide information about the situation that is happening in the graph. We have our independent scale, which is our independent variable x, or it could be t for time in this case, where we have time and our units is minutes. We have our dependent variable, which is distance, could be d for distance, and our unit is meters. We have the general shape of the graph that shows a steep increase, a steep decrease, no change, a moderate increase, steep decrease, and a moderate decrease. So the shape of the graph is very important, especially when you're looking at movement or time or speed, and how it will increase or decrease and depend on the shape. A linear graph, maybe you're familiar with that from grade 9 when we talked about linear functions. A linear function has a constant change in independent and dependent variables. It will increase by the same number or it will decrease by the same number. The graph is described by a straight line. The line segment can be horizontal, vertical, or oblique. The direction of the graph can go up to the right, meaning it's positive, or it can go down to the right, which means it's a negative. Polynomial functions that are linear are always in the form of ax plus b, where the x variable has degree 1. The parameter a will tell us how steep the line is, if it's increasing or if it's decreasing. And b will give the location of the y-intercept. So this is really important to keep in mind, that it has to have only degree 1. Once you see an x squared term, that means it is nonlinear. A nonlinear graph does not have a constant change in the independent and the dependent variables. It may start off going up with 2 and then it could change to 4, could change to 8. It is not going to be constant, so therefore it will not produce a straight line. The graph may increase at the start and then decrease towards the ending point, which is a little different than in a linear graph. A linear graph will always increase or decrease, and it never changes like the nonlinear graph. And a curve is very popular when we talk about nonlinear graphs. Curves are used when the change in the independent and the dependent variable is not constant. So you could see a curve, you could see something that looks like a heartbeat monitor, you could see something that we looked at in the first example there with the characteristics of the graph, something that's very sharp, and a circular graph. All of those are examples of nonlinear. As long as the graph is not a straight line, we have nonlinear situation. So now a distance time graph talks about things that involve a little bit of physics, but we're not going to go too in depth. A distance time graph shows how an object's distance changes with time. So we're talking about distance and time, so how they interact with another. The graph can show how far an object has gone. A horizontal line on a distance time graph shows that an object was stationary, so that means it doesn't move during that time period. The straight horizontal line shows that its distance stays the same as time goes by. So they may went 5 meters and stopped for a period of 5 seconds or 5 minutes. A straight line moving upwards shows that an object's distance increases as time goes by. So something that is increasing is going to be moving along in time, and it's going to be changing in distance. And the object has a velocity, which means that it's going to move. The greater the increase of the line, the faster the object moves. So if we have something that is very steep in its line, is moving faster than compared to a line that is not increasing as fast. And we can see this in the picture here, especially with the red line, is we have a steady speed, then something is stationary in its distance as time goes along. So maybe someone's out for a walk and at 10 minutes they want to take a break. So the distance stays the same as long as the time continues. And when you return to start, you're decreasing in your distance, or decreasing in your distance, and you're going back maybe to the start. Or you can look at something like the green line, something that's going to be fast and a steady speed, or something that's gradually getting faster as it goes along. Maybe you're going for a walk and then you change into a run, so something's getting faster. And then we have a speed time graph. A speed time graph shows how an object's speed changes over time. The graph shows how fast the object is moving. A horizontal line graph shows that the speed of the object does not change as time goes by. The object will have a constant speed. So anytime you have a horizontal line, the time continues, but the speed doesn't change. A straight line graph moving upward shows that the object's speed is increasing as time goes by. Increasing speed is known as acceleration, which is a term that was probably mentioned in your 1206 science class. And as you can see from the graph here, we have a steady speed starting off, something is stationary, which means it is not moving, then you have something that's returning to the start. And again, A to B line there is a fast, steady speed. There's a sharp increase, which means something is moving fairly fast. And then A to the point very far up in the right-hand corner shows something that is gradually getting faster with time.